So, well, it's a pleasure to be here and to talk, learn about AI machine learning. So I hope that you are enjoying and learning a lot during this event. So yeah, as I was introduced, um, my name is Luis. I am a Microsoft AI and Developer Technologies MVP. And well, yeah, we are going to talk about ML.NET, which is basically a framework for developing, for building machine learning models using .NET technology. And well, we are going to make this a bit fun. So we are going to create a model that is used by a mobile application. So we will see how the tests go. So yeah, um, thank you again to the sponsors for yeah, they helped really to make this possible. So again, massive thanks to them. And well, besides what Nandip said about me, here you have my contact details in case you would like to discuss some topic later, or in case you have any questions. Here you have Twitter, LinkedIn, and also my email. Feel free to reach out. And well, yes, as Nandip said, I am based in Czech Republic, although I am from Mexico. Yeah, so I am here because of the studies. It is quarter to 9 a.m., which is a pretty nice time. In around 1 hour and a half, we will continue also with our Global AI Bootcamp, Latin America. We will have a couple of sessions in English. And later we will also have some other sessions, but in Spanish. So yeah, it will be quite an active morning. So yeah, this is my first session. I will have 4 today. All right, so let's move to our agenda. We will talk about deep learning, just as an introduction of what we are going to do in for our demonstration. We will talk about ML.NET. You can share in the chat if you have work with ML.NET, if you know about this technology. Then we will train and build a machine learning model. We will briefly talk about .NET. And finally, we will demonstrate with a mobile application and also a REST API in .NET Core 5 how we can use this machine learning model in some application. Okay, so let's go for deep learning. Deep learning is a subset of machine learning. It is a field that is based on learning and improving on its own by exploring computer algorithms. You know, machine learning uses simpler concepts, but deep learning works with artificial neural networks, really deep or complex artificial neural networks. And well, they are designed to imitate how humans think and learn. Until a few years ago, neural networks had a limitation or were limited by the computing power. So also they were not able to solve complex problems. However, the advancements in big data analytics, also in hardware or computational resources, allow nowadays larger and sophisticated neural networks. So now computers can observe, learn, and react to complex situations faster than humans. Deep learning is focusing on image classification, language translation, speech recognition, just to name a few applications. But essentially, it is used to solve pattern recognition problems without human intervention. As a concept, artificial neural networks comprise several layers. And deep neural networks are type of networks where each layer perform complex operations such as representation, abstraction of images, sound, or even text. Deep learning has this learning process that starts to understand or to create representations. It actually starts with an image. From the image, it will identify low-level features. They are minor details of the image, such as lines or dots. This will be picked up by a convolutional filter. We will explain this topic in the next slide. So, okay, these lines, these low-level features are taken by this convolutional filter to obtain, for example, edges. And these edges represent mid-level features, and this process is repeated, another convolutional filter, until high-level features are detected. So it can start to understand some forms, some maybe objects like a window, like a glass, or something like that. Larger shapes in the image. And well, yeah, until we reach to let's say even larger objects. The convolutional neural networks use both types of features. The first convolutional layers learn about filters to find lines, dots, curves. And the later layers recognize common objects. That's the idea. And what I explained for images can also be applied to text and also audio. For example, in text, you would say that if we are analyzing, let's say, a book, first, a deep neural network can recognize characters. Then, together, they form mid-level features such as words. Words belong to a group, and yeah, you can build this on top of clauses, sentences, or even create a story. So this is more or less the mathematical part. You know that an image is basically a matrix of numbers, right? So there is a convolutional filter. Convolution is a general purpose filter effect for images. The filters detect spatial patterns such as edges, lines, borders, dots by detecting the changes in intensity values of the image. How this is detected? Well, it's basically by the numeric value of the pixel. And actually, a mathematical operation is performed because this filter or this, let's say, matrix representation is used through the whole image. So mathematical multiplication of matrices occurs, right? So in the end, we will get a high frequency image where we will see some intensity of pixel changes, and there will be low frequency images where the intensity is uniform. Together, this image is known as convoluted image or convoluted picture. Basically, is the result of the mathematical operation, the mathematical application of the filter through the through the original or input image. If we go, let's say, a bit into details just to make this clear, this mathematical operation is quite common, okay, in image processing. So we multiply together two arrays of numbers. They can be different size or similar size, but of course it has to be a valid mathematical operation. Same dimensionality. And a third array of numbers will be produced. As I said, this is known as convolved image or convoluted image. It also receives some other names such as feature map. Okay, so then now you will see some animation about this mathematical operation, right? So we have the input image. Let's say we have a filter of 2 by 2. So okay, maybe we also take 4 elements. So we perform, right, this mathematical operation. If you remember about the mathematics, well, you know, this is the equation, right? And after that, we obtain this first value. Then we move through the input image, maybe one step to the right, and we repeat, right? Mathematical operation to obtain next value, and so on. Okay, but actually, right, between filters, we need to reduce the dimensionality. So we actually include another element, right? Okay, yeah, I will explain that one in the next slide because, yeah, this is basically application of convolutional filters, right? So we have first filter, second filter, and so on, right? This is just an extension of what I explained previously, right? But as I was saying, in the, let's say, real world, in convolution neural networks, actually, we apply an intermediate step, which is known as pooling, to reduce the number of dimensions. There are typically two approaches, max pooling or average pooling. So let's say that we have some convolved image, right? And basically we determine some filter size, right, with some stride. The stride is basically the step. So let's say that we are taking max pooling, or we want to apply max pooling with 2 by 2 filter with stride of 2. So we will take the maximum value of this, let's say 2 by 2 window, right? 1, 3, 4, 2. So the value is 4. Then 5, 3, 3, 1. The maximum value is 5, and so on. For average pooling, it's exactly the same, but instead of obtaining the maximum, you obtain the mean, the average, to get your output matrix. And it is quite clear that now, instead of this representation of, let's say, 4 by 4, now we have 2 by 2. So the number of elements is reduced. Okay, so that's the goal of pooling. And in convolutional neural networks, basically we have convolutional filters and then pooling operations. So we have the image and we apply, right? So a convolutional filter, max pooling, convolutional filter, max pooling, and so on, until we reach a vector, right, which is known as the output vector. And we can also create fully connected layers structure to determine what is the category, for example, of this image, right? Is it a living room? Is it a kitchen? Is it outdoor? And so, okay. So more or less, this is the idea behind deep learning, right, for image processing. Similar thing could be applied for object detection, right? But also you need to consider the location of the position of some objects, okay? So, but we will talk about image processing. So, well, yeah, that's the idea. But now we have ML.NET. Okay, to perform deep learning, you can do it by using Python, right, which is maybe the most known language for neural networks for deep learning, right? There are some libraries such as TensorFlow, for example, which is also highly used. But if you are a .NET developer, well, there is a, let's say, solution or there is a technology that you can use, which is ML.NET. Basically, this is an open source and cross-platform machine learning framework for .NET developers. So you can use C# or F# to create machine learning applications. Even you can you don't need to be a developer, because there is also a model builder which allow you to create a machine learning model without writing a single line of code, and the output will be a console project, right, which performs all the analysis for you. Basically, with model builder, you have a wizard. So you provide your data, you state, let's say, the maximum time for your experiment, and then it will determine what is the, let's say, for example, if you want to classify images or data, what is the algorithm that gets the best performance, right? The best accuracy or metric. So yeah, that's the idea. And this is quite classical machine learning task. But as I said, there is a model builder extension in Visual Studio that you can use, and then you will obtain the best algorithm for your data. But we are going to focus in this case for the development, okay? Yeah, and you can actually interact with TensorFlow models. You can import a TensorFlow model that you created, right, with another technology. It can be, of course, with Python code, or even some other technologies such as custom vision. You probably know custom vision from cognitive services. You can export the model to different platforms such as Onyx, TensorFlow Lite, right, Core ML, and so. So in this case, you can take that custom vision model and perform some operation such as transfer learning, right? But yeah, that's also some other topic for further discussion. And well, ML.NET can be used to solve different scenarios, which are quite classic for machine learning, such as object detection, image classification, regression for price prediction, fraud detection, sentiment analysis. Yeah, there are several, let's say, applications that you can create by using ML.NET. If we go into details, well, for developers, right? First, you need to add the ML.NET NuGet package in your C# or F# application. Then you will use or create an ML context object, which is the starting point for all the operations in your machine learning project. So you can use this project, for example, sorry, this class or object, ML context object, to transform your data, to perform some normalization operation, to perform feature engineering, export your model, train, predict, and other operations. In most of your lines, the ML context will be present. You will see. Of course, for example, if you have worked with scikit-learn for Python, and you know that there are data frames, right? Pandas, data frames, and so on. So something similar in ML.NET, we have iData view, right? So we might have our data, let's say, in files or in a database, even in memory, right? So let's say we have our data set. So the schema is basically class definition. You indicate the columns, right? The property names are not important at all. I mean, they don't have to match the name of the column, let's say. Maybe this is a CSV file or whatever. The important thing here is the attribute, right? For example, here we specify, okay, load column 0, column 1, and so, right? So for example, you can see that here the column name is flower type, but here we call it label, which is totally fine because it will load here in this property the value of the first column, right? And this is second column, third column, and so on. So you have your data schema definition, and after you perform some operation, which is load data view, you will have in memory an iData view object. This is what you are going to work with in, for example, your training pipelines. Similar to what you would do in scikit-learn with the data frames, for example. Okay. So yeah, all your data will be loaded in an iData view instance. Okay. Well, yeah, and there are several operations that you can perform in ML.NET. So yeah, such as normalization, for example. Also, some classic operation is that maybe your data is incomplete. There are some columns which have missing data. So definitely you can also perform some transformation. For example, you can remove the rows with missing data, although that is not recommended. You can replace these missing values with the average of the other rows, right, for that specific column. Or maybe you can also check if your data is normalized, or even normalize it to some scale, to some value. You can also perform feature selection. And also there are several algorithms or learners that you can use, right? For clustering, for classification, for regression, right? And well, yeah, you can also interact, as we said earlier, with models that come from other frameworks such as Onyx, TensorFlow, and so on. And also something classical from machine learning. In the end, you are going to get a model. You can export it. You can take it so it can be used by other applications such as desktop applications, web applications, or even mobile applications. Well, right now, mobile applications, you cannot use them directly. Although, well, I was reading that ARM templates can be used, sorry, ARM architectures can be used, but for example, Xamarin, not yet, right? So probably something native. For mobile, which is the demo that I'm going to showcase, I'm going to use a web API. Yes, I can take my machine learning model, which is a serialized zip file that includes three things: the data schema, the data transformation, and the learner, right? So I can take this model and paste it in my web application for data prediction. And of course, ML.NET can be used for deep learning operations, right? So in this case, thanks to the TensorFlow .NET C# binding, you can interact with your, let's say, code and perform include different models, pre-trained models such as Inception or ResNet, right? For image classification, also BERT for text classification, or even for object detection, you can use YOLO. So yeah, you can perform deep learning operations or tasks in our ML.NET applications. And actually, that's the demo that I'm going to showcase. So here I have Visual Studio with the model, with the code, but it might be easier to continue showing in the presentation, because yeah, I have the code, let's say, a bit more organized. So first of all, in our project, we have the NuGet packages. As I said, well, we will include Microsoft ML NuGet package, and in image classification tasks, you also have to include these three: Microsoft ML Image Analytics, Microsoft ML Vision, and C# TensorFlow Redist. Then, as you can see, we also have two projects, although you can do it everything in a single one. But one is just a .NET standard project, which has the data schemas, right? If you remember, we defined that concept earlier. So here we have the hand gesture, and this is for the prediction. This is for the output, okay? And you will see how is my data. But let's say we have hand gesture. If you remember, we want to create a rock, paper, scissors game. So we will have different images or different pictures. I think I have that here, right? So I already have, or there is also, sorry, there is already a data set with different folders. In every folder, there are different representation. For example, you have a rock, you have paper, you have scissors, and so, right? In different folders. So this representation is included in this class, right? So we have the hand gesture class, we have the image path, we have the actual gesture, and also the subset. The subset is basically if it is for training or for validation, right? Because you need to evaluate if your model is accurate, if works with unseen data, right? So, okay, this is the structure. Then we have the program CS, where we have all our code. In program CS, first we have, let's say, the paths. Where is our information? There is different folders, right? One for rock, paper, scissors training, other for validation. Also for the output, for the model, because I told you that I'm going to take this model and include it in another type of application. So yeah, I need to export my model, right? And as you can see, there is one method which is known as prepare set. Basically here we are obtaining all the files from a specific directory. This is C#, this is no ML.NET, this is just basic C#, okay? We will obtain an IEnumerable collection, sorry, an IEnumerable of hand gesture. and we are populating our three properties, right? Image path, actual gesture, and subset. Then we have the load images, which basically, let's say, calls the prepare set method, right? And this is just print message because we are going to send to the output a lot of information. You will see a lot of messages. I already explained about our data set. And this is the pipeline. This is basically the main code, right? Although there is one line missing here, but it comes in the next slide. So essentially here you can see that first we load our data. There are two collections, training and validation. One is for the T subset and the other one is for B subset. Everything here will work with training, right? And validation will be used later after we already created a model to evaluate some metrics such as accuracy. So, and you can see also one of my first lines is the instance of ML context, right? And this context is used here, here, here. I told you that the context will appear through our program, right? Then we perform some transformation. First, we read the path of every image, but now we are applying a transformation. The transformation is basically opening that file because, as you can see, this string is going to be converted into an image bytes column, right? So later we are going to open it. Okay, so this is, yeah, actually you can see the method load raw image bytes, but I said later because when I execute this line, if you actually debug it, it will immediately go to the next slide, and you might wonder, okay, but if you have around 2,000 images, did the program like ML.NET load this huge amount of data in 1 second or less than 1 second? Well, actually, this is a plan. This is a transformation. The data loading, sorry, the transformation of or converting your string into byte array has not occurred yet, right? This is a plan. This is just a pipeline. The operation will happen later. I will tell you when. So, but when this operation is performed, yeah, the images will be loaded in memory. As I said, not yet, but when it happens, it will. Okay, so yeah, we are adding this into a pipeline. Then there is also another pipeline, which is known as training pipeline. In the training pipeline, we specify, for example, the architecture that we are going to use, such as Inception v3, it could be ResNet as well, right? And also some other options, such as printing the metrics, right? We want to send this to the output, for example. And for the training pipeline, we specified that we want to perform image classification task. Okay, so as you can see, well, yeah, it's a bit of understanding the different classes, but to be honest, ML.NET team has written quite an impressive documentation, so you will not get lost. You will, if you check the documentation, you will be building your ML models in 10 minutes or even earlier, right? And most of the times when we perform a transformation, okay, we have an input column and we transform it or we rename it, right, into another column, or we can create another column with that data, right? This is classical machine learning, well, pre-processing task, okay? Not machine learning yet, but pre-processing task. Okay, and after that, you see that I have a full pipeline, which is basically, okay, we have the load pipeline. After this is executed, appended the training pipeline. But as I said, this code will execute quite fast because this is just a blueprint. This is just an idea, some plan. When we call the fit method, the training process starts. Well, actually, everything that we said earlier in the pipeline will be executed. Okay, so in this line, this is the one that will take a lot of time. Actually, in my case, I run this code before entering this session, and it took around 20 minutes or so. So you see here I printed the time, so it was 8:42, but it started. Okay, probably I cannot see because yeah, it is full. But it started around 8:20 or something. Yes. And well, a lot of information is appearing in the console. So it is loading every image, and after that, well, you know, in machine learning, we have epochs, we have let's say loops, right? Where the goal is to apply the algorithm, perform the task, and improve the accuracy or the metrics, right? So you can see how the accuracy is increasing every time, or maybe the learning rate is decreasing. At some point, the learning rate will be really low because it means that the, let's say, neural network is a bit stuck. It's not learning anything new, right? So yeah. And of course, something that I did not mention is that for deep learning tasks, you need GPUs. The GPUs can perform this operation quite fast. In my case, this computer is a CPU, so that's why it took around 20 minutes. But if it was a GPU, probably in less than 1 minute, or okay, I might be exaggerating, maybe 2 minutes, it will perform everything, right? But yeah, that's the year. In the end, we have created a machine learning model. It is in memory, right? That can identify gestures, hand gestures, okay? And I will go back to presentation. Okay, yes. After the model is trained, right? I have it here. Then we can take our second data view and yeah, you use the model and predict all the images there, right? So you can see the operation here, right? There is context, multi-class classification. Yeah, something that I did not mention, right? We have 3 classes. That's why this is a multi-class classification task. We have the evaluate model. We take the predictions data view that I mentioned earlier, right? From the validation image data view or collection. And yeah, we are going to obtain some accuracy, some metrics. In our case, for this new data, of course, this predictions data view was not used for the training, right? So it is using new data. The macro accuracy value obtained was, let me check. Okay, 79.61%, more or less, right? So around 80%. So we might need to improve this a bit, but okay, this is just a demo, so that's totally fine. We might add more data. We can, yeah, find some ways to improve it. We can also check if the classes were balanced. What I mean is that if you have similar numbers of every category, right? Maybe I have 500 hand gestures, let's say, or for the hand one, but maybe I only have 100 for scissors. This is not balanced class example there. So we also need to aim for that. Okay, so after we obtain the macro accuracy, then this is some prediction for new data. So in this case, I also have another collection. Okay, just a second. Let me check. So as you can see, well, I don't want to use those. I wanted to use. Well, yeah, okay. We have some some files. This is test rock. This picture was not used for training. So this is the actual gesture, and what the model said, okay, this is a rock. Okay, so this is correct. But as you can see, the model is not perfect. It might encounter some issues. For example, here, this one is paper. The image 01-29 is paper, but actually the model says it is a rock, right? So it is not perfect at all, right? But okay, for our example, 80%, we will consider that is nice, okay? So yeah, that's the idea. We need to evaluate, we need to check if our model is accurate. Depending on the scenario, 80% might be enough, or on the other hand, quite low, especially if this is a machine learning model that is used for human lives, or maybe to give some credit, you want the highest accuracy possible, right? Yeah, okay. So in the end, we save the model. To do that very easily, you have the save method, right? And of course, there is also load method. We will use the load method in the web API project. And after a model is loaded in memory, we can then use the predict method, which I think I don't use here. Yeah, I think I don't use it, but we will see it later, okay? It is here, yes, in the consume model. So as you can see, we load the model, and then we have the, we create a prediction engine, right? This prediction engine has a predict method. So you will see actually in our API that we will use quite similar methods. The idea is that the user, for example, will send a picture, and the model, of course, I don't need to train it anymore. The model is already there. So we will load it in memory. It will receive the picture that is sent, let's say, through the network, and then it will predict. The result will be a label, a string, right, with the output, what the model thinks this image is. Okay, and this is just the output that I already explained, right? And some results. Okay. Yeah. So you can see some examples and the results, right? So for example, this is T1, and it is scissors, right? This is T4, and this is paper. Yeah, there are several examples. But this is what we want, right? So after that, we can use this model in different type of applications. For our scenario, we are going to use these two, right? We're going to take the model to the web and consume it, consume the web API from a mobile application. Okay, and this is possible because everything can work through .NET standard. And well, nowadays we live in .NET 6 world, so it is even easier. Okay. So let's demonstrate that. And in this case, okay, I should have run this application earlier. But okay, um, while the emulator is running, you know or you see, this is my console application, but I don't use it here anymore because the model is already trained. I have a mobile. This is a Xamarin application, but I also have, before it loads, this web API project. This is, as I said, a .NET Core 5 project. It has a controller. This API is already published in Azure as an app service. So actually in the mobile application, I call that one, right? So here, please take note, this is a classified controller. This is something that I created in my web API project. And here I already have the engine pool, right? The engine pool is created in the startup class and injected, right? So here you can see prediction engine pool. And after that, we have some methods exposed by our web API. And here we have, okay, just some validation that the picture exists, but we have the predict method, okay? So in this case, we take the location of the file, we create a temporary file, and we use it. So it will, the model will open the picture and it will tell us something. What is it? Is it rock, paper, or scissors, right? And we will return this. Yeah. So now I can show you this application. Okay, this is still loading for some reason. Not sure why it is taking a lot of time. Okay, yeah, thank you. So let's demonstrate it. So let's take a photo. I will share, or I will explain the Xamarin code in a minute, just a second, because, okay, yeah, okay. I need to, because I am using an emulator, I need to rotate my phone temporarily, so sorry about that. And it will be a bit slow, but okay, let's start with some example. Okay, just a second. It is a bit complex to handle this, but okay, because it is a bit confusing. Okay, let's try this one. All right. Now let's rotate it. Let's say yes. And yeah, when I present this is slow for some reason. Okay, let's classify. Let's see what the model says. While we obtain the result, you can see that my mobile application, it has a view model, which is the play, and for that button, if you have worked with MVVM, you might find this familiar. When I click that classify button, there is a command, and the command calls the classification service dot classify method. This classify sends the picture, as I said, to a service. This service is here, right? This is an app service, okay? And it will call the classify controller or method, right, that I mentioned earlier. And after that, we will obtain a result. Okay, yeah, this is an error. As I said, the model is not perfect. So, well, let's try another one. And this second result, this is just something random, right? So let's try again. Okay, let's see if this time it works. So, okay, let's take a photo. Let's rotate this. I will try this now. Okay. Okay. So. Okay, now let's rotate it. And let's classify it. And let's see if we get a hand. Okay, well, well, my model is not behaving. It was working. You know, it always works before we test it, correct? Okay, so let's just try some final example. But yeah, as you can see, well, we are just communicating all the applications that we created. The basis, of course, is the creation of this machine learning model. Then the rest is just an application of this solution, right? Okay, so hopefully this one will work. So let's see. And let's click on classify. And the result is no, it is not working. Okay, well, it happens, but I can assure you that it works. Okay, in case that you would like to run this on your own and actually publish it in an app service, you need to consider that in the settings of your app service, you need to change the platform architecture to 64 bits. Because if you keep it as 32, which is the default, you will obtain this error that the TensorFlow library was not loaded. So this is some consideration. And yeah, and also you need to include your Microsoft machine learning packages in your web API. This is something else that you need to consider. And finally, well, I was getting an error if I am using the latest version of TensorFlow, sorry, Sci-Sharp TensorFlow. Redist 2.4, I was obtaining an error. So I am using this specific version 2.31. You can see it also here. Okay. And well, yeah, that's basically all from me. If there is any question, I will do my best to try to answer them. So